Today in this video, we're going to attempt to reverse engineer Royal Raymond Rife's famous BX mortal oscillatory rate. That would be Bacillus X, as he named it. And how we're going to do this is we're going to look at the photograph of the 1934 Scripps study Rife machine. This is the machine that was used to effectively treat 16 patients. And this is the machine that derived all of the original Rife frequencies. This is referred to as the Rife number 3 machine. The frequencies were generated by the use of two Kennedy receivers. On the top here is a Kennedy Model 281, and on the bottom is a Kennedy Model 110 receiver. The inputs of these receivers were used as frequency generators. You could do that with these receivers. These were regenerative receivers, and so when you increase the regeneration amplitude, you would get a carrier signal outputted from the antenna inputs, and these receivers turned into wonderful and accurate frequency generators at that point. Now, if you do an AI enhancement of this old black and white photograph, you can derive what the connections are in how the radios are connected up. And we've done this, and this is the diagram that we have derived. The antenna input from the Kennedy Model 110 is connected to the antenna input of the Kennedy Model 281. And that takes two different carrier frequencies and it heterodynes them together. And so we've actually set this up on the workbench with the genuine equipment used back in 1934. And we've duplicated the connections. The bottom receiver is running at a frequency of 1.8 megahertz, and the Kennedy 281, the top receiver here, is operating at a frequency of 1.604 megahertz. When you connect them both together, connect their antenna inputs together, and use them as frequency generators, what you get is like a crossed wire mixer, and you derive a beat frequency. And we can see that on the oscilloscope. Right now, these Kennedy receivers are powered up and operating live via these batteries in the foreground here. They are hooked up as the Rife Lab Batory photograph is indicating, and that is the beat frequency. What you have is a carrier frequency inside here, and that becomes the average of the two frequencies that are heterodyned. F1, frequency number 1, is 1.8 megahertz. F2 is 1.604 megahertz. They heterodyne together to create an average frequency of 1.702 megahertz with a beat rate of 196 kilohertz. Okay, that is That is the effective signal that Rife was using. Now, if we connect our scope probe to the output of the second Kennedy, this is where, let me go back to the diagram. This is where the diagram gets real busy. The second Kennedy output is connected to the output of the RC2, and here we find an interesting waveform. We find it looks like an AM waveform of the signal. We can view that on the scope. That is set on my channel 2. And there it is. Okay. We're seeing a very pronounced 1.604 megahertz carrier wave, but it also does contain some of the 1.8 megahertz. And the AM looking signal riding on the top and the bottom is occurring at a rate of 196 kilohertz. But this signal is pretty much too weak, too low in amplitude to do anything with. And this was not the effective signal that Rife was using in his system. This signal, I have it drawn here. I'm reading about 250 millivolts peak on this. Okay, I'm sure he used that as a marker frequency. The marker frequency was what this system was all about, because the Kennedy Model 281, it was very, very hard to identify what frequency that was operating at. So if you're going to use these receivers as a frequency generator, namely to create the correct Rife frequency for his mortal oscillatory rate of whatever microorganism or disease he was targeting, he would use the heterodyne setup. And at this point, you would get a beat frequency, and I measured 3 volts peak to peak at the height of the amplitude. That's the most I could get out of it. Back 100 years ago when Rife was doing it, I'm sure his vacuum tubes were a lot stronger, and so he was probably getting more amplitude. Now, if we come back to looking at our heterodyne frequency, what we're calling the effective frequency and waveform that Royal Rife was using on his Bacillus X mortal oscillatory rate. This is what it looks like. If I broaden it out, you can see it's pretty much a perfect beat wave. Now that is the heterodyne of the two frequencies. If I disconnect that input and place it inputting on my spectrum analyzer, we can analyze the frequencies. We get 2 peaks together. This peak is occurring at 1.604 megahertz. And you can see the cursor is riding on top of that, and it's reading out 1.604 megahertz. And so if we put the cursor on this peak, it should be 1.8 megahertz. So I'm going to do that. Okay, hit next. There it is. That's it. You can see it's exactly 1.8 megahertz reading out, and the cursor is on this second peak. So as we are looking, I'm going to replace the connection back into the oscilloscope so we can see. I lost my picture. That's nice. Now here it is. I'm going to connect up. There you go. Okay. I will adjust the triggering, and there it is. So inside the average carrier, we see both frequencies represented, the 1.8 megahertz and also the 1.604 megahertz. They both average out to be 1.702 megahertz, and that's what the scope shows us, is the average. Okay, that's pretty much a reverse engineering of what Royal Raymond Rife was doing back in 1932 to 1934.